Okay, hello everyone. Thank you for coming today to my talk on exercise in the brain, which is basically a combination of my two main interests, brains and exercise. So a little quick recap before I get started. An axon is a part of a neuron that receives information from other neurons. A dendrite is the part of a neuron that sends information to other neurons. Your hippocampus, which is the main part of the brain that I'll be talking about today, is involved in memory and learning. This is what we're going to go through today. I have a bunch of different subtopics that we're going to talk about. So I'm going to introduce the field and then go into exercise and neuroanatomy, cognitive function, the neuroprotective effects, BDNF, exercise and BDNF, mental health, attention, what type of exercise is best, and CDC guidelines. Beauty. Oops, I should not knock that over. Okay, so exercise has been shown to have numerous benefits on the brain. Regular physical activity can improve cognitive function, protect against brain deterioration, and decrease the risk of developing brain-related diseases such as Alzheimer's disease and depression. In this seminar, we will explore the various ways in which exercise can benefit the brain and discuss the current research in this field.
So physical exercise has been proven to have some of the following effects. Number 1. Boost the memory. Studies conducted on the hippocampus among children, adults, and the elderly showed that the brain structure grew after aerobic exercise. The hippocampus is part of the brain that holds the memory and is therefore crucial for learning. Number 2. Improve concentration. Exercise improves the ability to focus on one task, ignore distractions, and also hold and manipulate information. Aerobic exercise improves retention among students and therefore crucial for children, adults, and the elderly as well. Number 3. Improve mental health. Physical exercise is a great mood enhancer. The feeling of elation experienced after exercise is real and should be used as an alternative stress reliever. A 2010 study conducted for 8 weeks showed a significant decrease in the amygdala after yoga and meditation. The amygdala is part of the brain that is implicated in processing stress, fear, and anxiety. Number 4. Slowing cognitive decline. Physical exercise delays the onset of mental wear and tear and dementia, especially among the elderly. It pays to exercise early in life to avoid mental illnesses that come with old age. A study published on the neurology suggested that women who were physically fit in their middle ages were 88% less likely to develop dementia than their peers who were only moderately fit. 5. Physical fitness and weight loss. A study published in the Indiana Journal of Endocrinology and Metabolism showed that an active exercise training program was ideal for reducing weight and improving physical fitness among obese children. The effects were possible even without a change in dietary composition. Number 6. Protection of the body against age-related decline. According to a study published in the Journal of Aging Research, it suggests that physical activity maintained throughout life is accompanied with a lower risk of developing chronic conditions such as cancer, diabetes, cardiovascular, and coronary heart diseases associated with chronological aging. Number 7. Improved heart and lung health. When done on a regular basis, physical activity, both moderately and intense, lowers the risk of developing coronary heart disease. Regular exercise strengthens the heart muscle and its ability to pump blood to the lungs and the rest of the body. The lungs automatically pick up the pace to keep up with the exercise and therefore become stronger as well. Number 8. It increases lean mass and strength. High-frequency training and low-frequency training both contribute to improvements in lean mass and strength in men and women. Strength training also helps alterations in metabolism, increase in bone density, reduce the risk of injury, and even rebuild lost muscle. The buildup of muscle is necessary for preventing a resting metabolic rate that causes obesity. High-frequency training and low-frequency training both contribute to improvements in lean mass and strength in both men and women. Number 9. Improved cholesterol levels. Regular physical activity and exercise are effective in lowering cholesterol levels in the blood and thus preventing the onset of coronary heart disease, heart attacks, and strokes. Clinicians recommend aerobic training or resistance training to ensure that healthy cholesterol levels are achieved. Number 10. Prevention and management of diabetes. Regular exercise can help delay or prevent the development of type 2 diabetes by 60%. Daily physical activity, aerobic training, or resistance training prevents sugar buildup in the blood. insulin sensitivity increases and the body can take up glucose during and after activity. Any form of physical activity that helps the body burn calories, e.g. walking, cleaning, running, sports, is beneficial and should be included in daily routines. So in conclusion, daily physical activity and a variety of exercises have significant improvements on the brain and the body among children, adults, and the elderly. Therefore, it is important to include regular exercise in our daily routines to maintain a healthy body and also to prevent lifestyle diseases.
So now, after that introductory video, we're gonna dive into exercise and neuroanatomy. So starting off on the more technical side of things with the neuroanatomical changes that physical activity induces. Exercise has been found to have a positive impact on neuroanatomy, the structure of the brain. Studies have found that regular physical activity can lead to structural changes in the brain, including an increase in the size of certain brain regions and an increase in the number of connections between brain cells. So an increase in the number of synapses. Specifically, a meta-analysis on the influence of exercise on brain health found chronic physical activity to result in structural alterations of the brain. These alterations include increased neurogenesis, which is formation of new neurons, increased synaptogenesis, formation of new synapses, those connections between neurons, increased angiogenesis, formation of new blood cells, and increased brain volume. Note that these benefits were not achieved with only a single bout of exercise. It is in the cumulative effects of physiological stress induced by exercise that is the key here. Further, a study published in the Journal of Neuroscience in 2016 found that regular aerobic exercise increased the size of the hippocampus, a brain region important for memory and learning. In addition, a study published in the journal Frontiers in Aging Neuroscience in 2015 found that elderly adults who engaged in regular physical activity had increased gray matter volume in areas of the brain involved in attention, executive functioning, and memory. Additionally, research has suggested that regular physical activity may lead to neurogenesis in the hippocampus specifically, which would only just increase memory and learning. Note that previously it was believed that neurogenesis did not occur in the adult human brain. This belief was based on the fact that scientists were unable to detect new neurons in the adult brain using traditional techniques. However, research in the past few decades has shown that neurogenesis does occur in certain regions of the adult human brain, specifically in the hippocampus and the olfactory bulb, so that includes your smelling senses. So while the rate of neurogenesis in the adult brain is much lower than during development, it is understood to play a role in certain brain functions such as learning and memory. So interestingly, a study examining hand grip training and its effects on the brain in minor acute ischemic stroke patients found grip training to improve cognitive function by increasing the local efficiency of brain white matter connectivity. So white matter in the brain is found in deeper brain tissues, and the nerve fibers are covered in myelin. That's why it's referred to as white matter. So myelin's an insulating layer around nerves that help neural signals travel along the axons and dendrites faster. So it accelerates the speed of communication between neurons. In multiple sclerosis, for example, immune cells attack the myelin in the brain and the spinal cord. White matter is essential for information processing and affects the ability to focus and learn, solve problems, and stay balanced when walking. So this study suggests that white matter rebuilding is a potential physiological mechanism that connects grip training to cognitive impairment. So exercise helps build white matter potentially in the brain, which then also ends up helping your brain work faster and those neurons connect faster and communicate better. So now we're going to go on to exercise and cognitive function. So one of the most significant benefits of exercise on the brain is its ability to improve cognitive function. So studies have shown that regular physical activity can increase brain plasticity, or the brain's ability to change and adapt in response to new experiences, in addition to improving memory, attention, problem-solving skills, and overall brain function in children and adults. A meta-analysis of 39 studies found that physical exercise leads to significantly improved cognitive function in older adults. Another study found that regular aerobic exercise leads to increased brain volume in regions associated with memory and learning, thus improving overall cognitive function. Further, working memory can be improved through exercise in older adults. So working memory is basically what you're working on at the current moment. So if you're problem solving something, you're using your working memory there. Moreover, research has also shown that exercise can improve cognitive function in children and young adults, indicating that the benefits of physical activity extends across the lifespan. So a study looking into how regular exercise changes the brain found exercise to help memory and thinking. Specifically, it found these cognitive benefits to result from the ability for exercise to reduce insulin resistance, reduce inflammation, and stimulate the release of growth factors. Growth factors are brain chemicals that influence the health of brain cells, angiogenesis, neurogenesis, and the survival of new brain cells. Exercise also has indirect benefits by improving mood and sleep and reducing stress and anxiety. Problematic mood, problematic sleep, stress, and anxiety can cause or exacerbate cognitive impairment. So thus, by exercise helping these factors, then we are indirectly helping cognitive functioning by removing or reducing anxiety, stress, etc. So as such, research has suggested that compared to people who don't exercise, people who exercise regularly have increased brain volume in the prefrontal cortex and medial temporal cortex, both areas that control thinking and memory. So especially your prefrontal cortex is involved in your working memory as well, and also pretty much most thinking you do.
Bigger brain.
Yes, bigger brains for people who are exercising. Okay, so now we're going to move over to the neuroprotective effects of exercise. So there's a long history showing that exercise protects against neurological damage seen in humans with Parkinson's disease, Alzheimer's disease, stroke, multiple sclerosis, traumatic brain injury, and a variety of other neurological diseases. Specific to multiple sclerosis, animal models of MS show exercise not only protects the brain, but helps repair it. So again, in multiple sclerosis, mainly your immune cells start attacking that myelin, which decreases the speed in which your neurons can communicate, right? So this study shows that people with MS should be incentivized to remain physically active due to its benefits for brain function and repair. Physical activity has also been shown to alter plasticity in the brain. A study found treadmill exercise to improve dendritic growth, which is the one neuron's connections to other neurons. So improved growth means that more neurons can talk to other neurons, increasing your connections in the brain. As such, participation in regular exercise is important for the maintenance and improvement of brain health across the lifespan through this increase in neuroplasticity. Beneficial effects are realized almost immediately, as a single bout of exercise briefly improves cognitive function after completing that exercise. So although prolonged chronic exercise has lasting benefits in the brain, even one bout of exercise can have immediate benefits right after that. That are transitory, albeit, but still great. So this post-exercise time period opens doors to strategically prescribe cognitively stimulating activities for enhancing brain plasticity and function. So further, a cross-sectional study looking at the relationship between physical activity level and subjective cognitive decline found the prevalence of subjective cognitive decline to increase as physical activity levels decreased. So people who were less active found to report more cognitive decline in older age than people who were more active. So further, they found that as physical activity levels decreased, the prevalence of functional limitations increased. So again, people who were working out less tended to have more functional limitations. Maybe they couldn't jump or sit up quickly. So notably, a clinical trial on strength and brain training in older individuals with mild cognitive impairment, which is a precursor to dementia, found strength training to result in overall benefits to cognitive performance and to protect specific subregions of the hippocampus from degeneration. So as mentioned earlier, the hippocampus is involved in learning and memory and is a region of the brain particularly vulnerable to the beta amyloid plaques that cause Alzheimer's disease. So one of the researchers on this study, Dr. Valenzuela, is quoted saying, "This is the first time any intervention, medical or lifestyle, has been able to slow and even halt degeneration in brain areas particularly vulnerable to Alzheimer's disease over such a long time." He also said, given this was also linked to protection from cognitive decline, the message is clear. Resistance exercise needs to become a standard part of dementia risk reduction strategies. Additionally, a meta-analysis looking into the effects of resistance exercise on neuroprotective mechanisms, oxidative stress, and cognition found resistance training to improve all three of these aspects of brain function. In general, in this field of literature, there's been much more research conducted on aerobic exercise and its effects on the brain, and the literature specifically on resistance and strength training is much more sparse. Albeit, the research that has been done on resistance and strength training proves just as promising as the research on aerobic exercise, or even more so. But more research is again needed to provide more concrete evidence on the benefits of strength and resistance training on the brain. Now we're going to move on to brain-derived neurotrophic factor. What the heck is BDNF if you've never taken a neuroscience course? And half neuroscience courses probably don't even talk about BDNF. So exercise also has neuroprotective effects on the brain. It can increase the production of brain-derived neurotrophic factor, BDNF, which is a protein that supports the growth and survival of brain cells by reducing neuron degeneration. So BDNF has been shown to protect the brain against degeneration and damage, making it a potential treatment for neurodegenerative diseases such as Alzheimer's and Parkinson's. Notice how I said treatment, not preventative chemical treatment. Wow. So additionally, effective depression treatments have been found to increase BDNF levels in patients who show improvement in their depressive symptoms. So as depression levels go down, their BDNF levels go up. So similarly, it has been proposed that lower blood levels of BDNF might be a biomarker for depression, and elevated blood levels of BDNF might be a biomarker for the successful treatment of depression. So now BDNF could potentially be a way to determine whether someone is susceptible or at risk for developing depression, and to see if this treatment is actually beneficial in depressed patients. So it has been hypothesized that the antidepressant-induced increase in BDNF levels increase particular neuroplastic processes, such as increased neurogenesis in the hippocampus, that lead to decreased depressive symptoms. And also, while we're here, the amygdala is, I know it was mentioned in the video, so I'm talking a lot about the hippocampus, which is involved in memory and learning. The amygdala is basically the part of your brain that processes all negative information. So it is severely upregulated in depressed individuals. So if I talk about the amygdala and amygdalar response deregulation, then that's going to correlate with decreased depressive symptoms. So now we're going to move on to exercise in BDNF. So now that we know what BDNF is and its neuroprotective effects, we will now explore the research on BDNF and exercise. So a study conducted on rats found that running increased BDNF levels in the hippocampus, an area in the brain, again, associated with learning and memory. So additionally, exercise has been shown to improve the survival of new neurons in the hippocampus, which is important for maintaining memory and learning. Specifically, studies have shown that acute exercise upregulates the expression of BDNF and increases regional activation and arousal of brain areas involved in cognitive control. Finally, a study investigating BDNF response to small muscle mass exercise found forearm hand grip exercise to significantly increase serum BDNF, platelets, and BDNF per platelet. So again, the research is showing that when you exercise, your BDNF levels in your brain are increasing, which again, just helps with neurogenesis, helps with your neuroplastic processes, helps your brain be able to adapt when you encounter something unexpected. So all benefits to your brain. Okay, now we're going to talk about exercise and mental health, which is a huge topic here. So in addition to its cognitive and neuroprotective benefits, exercise has also been shown to decrease the risk of developing mental health conditions such as depression and anxiety. Recurrent physical exercise can help reduce symptoms of depression and anxiety, improve mood, and promote a sense of well-being. Regular physical activity can increase the production of endorphins, which are chemicals in the brain that promote feelings of happiness and well-being and act as natural painkillers and mood elevators. Exercise can also help reduce stress and improve the ability to manage stress by increasing the brain's ability to cope with stressors. A systematic review of randomized controlled trials found that physical activity is effective in reducing symptoms of depression. Again, relating to BDNF here. So moving forward, exercise can also improve sleep, which is essential for maintaining overall mental health and promoting mental well-being. Furthermore, research has also shown that exercise can be effective adjunct treatment for individuals with anxiety disorders. So I just want to touch back on endorphins here. So exercise, we all know, increases endorphins. So again, I mentioned that endorphins are actually natural painkillers. So exercise actually helps your pain threshold and your pain sensitivity. So people who are experiencing pain and exercise need more noxious stimuli, so more painful stimuli, in order to have the same response as someone who is not exercising. And also, I wanted to mention that let me just reread this sentence for you guys. Exercise can also help reduce stress and improve the ability to manage stress by increasing the brain's ability to cope with stressors. So basically, when you're exercising, you are stressing your body physiologically, thus we're also stressing our brain, which then helps your brain be more comfortable with stress. Since we're putting our brain through this stress through exercise, it adapts and becomes more comfortable to combat other stressors in life. So more exercise means you're probably going to be less stressed, which is great. So now we're going to move on to exercise and attention. So exercise has also been shown to have a positive impact on attention and cognitive function. Regular physical activity has been found to improve attention, working memory, and executive function. Studies have also suggested that aerobic exercise in particular may be effective in improving attention and cognitive control in both children and adults. So one study published in the Journal of Sport Health and Science in 2019 found that after 12 weeks of regular aerobic exercise, young adults showed significant improvements in attention and cognitive function, including working memory and executive function. So another study published in the Journal of Clinical Psychology in 2018 found that adults with attention deficit hyperactivity disorder, so ADHD, who engaged in regular physical activity had improved attention, impulse control, and hyperactivity. So people with ADHD who traditionally have issues with attention, exercise can be a great treatment for them other than their regular medication that they might be prescribed. Furthermore, research has suggested that the benefits of exercise on cognitive function may be due to increased blood flow to the brain. So again, when I was talking about neuroanatomy, exercise increases angiogenesis, which is the formation of new blood cells in the brain. I mean, it's the formation of new blood cells anywhere, but we're talking specifically about the brain. So increased angiogenesis, increased blood flow, more efficient blood flow getting to your brain. So those parts of your brain that require blood and oxygen are able to get that faster than if you weren't exercising and building these blood vessels. So, as mentioned earlier, exercise has been found to increase the production of BDNF, which improves the communication between neurons, again, resulting in more efficient working memory, thus aiding in attention.
What I found was a series of, was a area of research that was growing and very exciting, showing that aerobic exercise can change the brain's anatomy, physiology, and function. Let me break that down for you. Let's talk about mood for a second. So we know that aerobic exercise can increase the same neurotransmitters that are decreased in depression, neurotransmitters like serotonin and noradrenaline. Exercise also increases the neurotransmitter involved in that feeling of reward when you win $1 million. Dopamine also goes up with exercise. Let's talk about memory. There's actually a large literature studying the effects of aerobic exercise in rodents. Usually they have the rodents running in running wheels. And what those studies have shown is that increased aerobic exercise in rodents actually stimulates the birth of many brain cells in that structure that I told you about that I studied, the hippocampus. Now, it turns out the hippocampus is one of only 2 brain structures in adults like you and I where new brain cells can be born. So without doing anything special, we all have a few new brain cells being born in our hippocampi. But with exercise, it pumps up the birth of those new neurons. And in rodents, not only do you get more brain cells, but their performance on memory tasks is improved. I don't know about you, but I want as many shiny new hippocampal cells in my hippocampus as I can get. That suggests that the hippocampus is important for imagination, a key component of creativity. And remember, I told you that exercise enhances the birth of brand new brain cells in the hippocampus, and at least in rodents, that also leads to better memory. This also raises the possibility that increased exercise might enhance our ability to imagine the future in a new way. So this leads me to my last of my 3 cascading paradigm shifts. This isn't a personal paradigm shift or a career paradigm shift. This is a paradigm shift at the level of society. Because what I'm saying is that these studies, looking at the effects of exercise on brain function, have implications for how we live and how we learn. What do I mean by that? In children, we should not be taking physical education away from the classroom. We need to start finding out a way to integrate it into the classroom to optimize the way that they learn. In adults, we don't only have to be looking for that magic pill to make us smarter. But what we really should be looking for is that magic exercise regime that will make all of these different brain areas that I've mentioned optimized.
So now we're going to talk about what type of exercise is best. So it is important to note that the benefits of exercise on the brain are not limited to any specific type of physical activity. Aerobic exercise such as running and cycling has been shown to be particularly beneficial, but resistance training and yoga have also been shown to have positive effects. Furthermore, the duration and frequency of exercise can also vary, with studies showing benefits from as little as 10 minutes of exercise per day. It seems to be that the type of exercise that is most beneficial is the type that an individual can keep a consistent routine with. If someone wants to experience the beneficial effects of exercise on the brain, but they hate running, then implementing a running exercise routine is probably not the best, as this person will probably not stick with that program. This person would likely not maintain that regime and thus not garner the benefits of chronic physical activity. People should choose exercise modalities that they can work into their daily schedules and stay consistent with. So whatever works best for you, as long as you're getting your exercise, will be best for you. Now we're going to go into the CDC recommended exercise guidelines. So the CDC recommends that most adults get 150 minutes or more of moderate intensity physical activity per week. So this is equivalent to 5 30-minute exercise sessions a week. So again, this is on the lower end, the minimum. But again, upwards of 7 days a week of exercise. That's also great, right? Because you're only just going to be improving all those things that exercise has on your neuroanatomy, like neurogenesis, synaptogenesis, angiogenesis, increased brain volume, all that good stuff. So following these recommendations can help individuals sleep and feel better, lose weight, reduce their risk of 20 chronic health conditions, including heart disease and some cancers, and add years to one's life, in addition to all the other benefits we have touched on today. So now we're going to be tying it all together. So in today's seminar, I discussed the many effects that physical exercise has on neuroanatomy, cognitive function, BDNF, mental health, attention, and its neuroprotective effects. So in conclusion, regular exercise has numerous benefits for the brain, including improved cognitive function, neuroprotection, neuroplasticity, and reduced risk of brain-related diseases and mental health conditions. So the current research indicates that the benefits of physical activity extend across the lifespan and are not limited to any specific type of exercise. And if someone's not physically active for the first part of their life, it's never too late to start, because they can still start garnering those benefits later on by starting to implement that exercise regime. Therefore, it's important for everyone to make physical activity a part of their daily routine throughout their lifespan. Thanks. And then if you want to press the next slide again. So I didn't plagiarize. Yay, do you guys have any questions?
Yeah.
Hit me. I'll try to answer them. I don't know if I'll be able to.
Well, maybe they're just like you're talking about mental decline and exercise, and that got me thinking, I know, a few people, but in particular, my dad, when he couldn't play hockey anymore because of his knee, like in his 60s or whatever, he stopped running so much, the mental decline accelerated a lot.
Oh yeah, totally.
Afterwards, I was thinking this was probably keeping him afloat.
Yeah.
He got his sharpness went way down pretty quickly after he wasn't moving as much anymore.
I mean, one comment on that is Alzheimer's disease is literally a combination. It's caused by a combination of beta amyloid plaques and neurofibrillary fibers in your brain. So two things that plaque and form little things in your brain that then relate to the memory and learning decline, cognitive decline in Alzheimer's disease. And exercise specifically regresses that development and also prevents that development. So then it's literally targeting the core of Alzheimer's disease, which has particularly in however many years we have known about Alzheimer's disease has been, you can't do anything about it. If you got it, you're just going to have it. You can't really treat it. You can just help manage the effects, try to keep your brain active. So exercise is totally one of those things that is needing to be more implemented. And it also spans towards Parkinson's disease too, which is just literally helping your brain control itself through Parkinson's disease because you have tremors and stuff. So exercise just benefits all of it. Sorry. I love this topic. Hit me.
So to add on to that, actually, like I'm kind of correlating with, people say like you can't teach an old dog a new trick kind of thing. It's like as you get older then, like say you had somebody that didn't exercise until they were 40 and then started exercising, as opposed to somebody that exercised all their life until whatever age, like 80s, 90s, if they could, would that first person still be able to kind of replenish and get to the same level as them, or is it kind of like you missed out?
Well, it depends, because your brain can only, like neurogenesis can only take place in certain areas of your brain, the hippocampus being one of them, which the hippocampus, again, memory and learning. So exercise literally promotes angiogenesis in that area of your brain, which then would directly affect learning. So that would have a huge benefit there. But the person who was exercising throughout their whole life would have more connections and other stuff in other parts of their brain and bigger and more brain volume. So especially in the prefrontal cortex, where we're talking about working memory and stuff. So what the prefrontal cortex is what you're using when you're driving and like doing daily activity and working memory. So that stuff, exercising later in life, could help increase the synapses, so the neurons connection between there, and also potentially increase the white matter, so increase myelination of those axons and dendrites, increasing the speed. But that would again be more of like a progressive thing. So that person would have to start exercising at 40 and be consistent with it for a while before they would start seeing effects. Although they would see like the very transitory like increase in attention and stuff after a single bout.
You mentioned, or like the lady mentioned, the reward, or feeling reward after workouts thing, and like getting dopamine hits, and that just reminded me. There's a few clients or a few people I know who, like, I don't relate to this at all, but they're like, they work out 7 days a week, or maybe a little less, but like they do it basically exclusively for mental health. Like, I'm doing this to feel good after, and it's like, so like, and someone like that, like me, I'm trying to maybe push them a little bit harder, get them out of the comfort zone a bit more, but maybe they're not interested in that.
Yeah, they just want to feel the benefits.
I'm just here to, you don't understand, I'm just here to move and feel better after.
Which is an interesting thing, because if you're talking about like in psych especially, like there's always this interesting conversation that goes around individuals who are dealing with depression, because the main thing when you're depressed is you have no motivation to do anything, right? So like we have this ongoing conversation in psych where it's like the best prescription you could give someone who's depressed oftentimes is start exercising and eating healthy. But it's like almost impossible, right, for people who are dealing with depression to just do that. Exactly. So it's like when you're talking about exercising for mental health, like you're not feeling that dopamine hit and that serotonin rush when you start your exercise. You're not feeling that before. So that motivation is, again, not being helped by that. So you have to have at least some type of motivation to push you into the gym to then experience those benefits later, right? Which is interesting, because like people who are coming to the gym for mental health, they're not getting it when they're on their way to the gym. They're getting it after they complete their exercise, which is interesting. And then it also promotes reward processing, because then when you start learning those connections, then you gain that motivation too. But like getting someone who is initially depressed into the gym can be a very daunting task. Yeah.
And then that the point about how the brain, like stressing the body helps, stress the brain or whatever, and that helps build resilience.
Yeah.
Or like doing hard shit here helps you do hard shit in other aspects of life. That's a really good point to kind of.
Yeah. And it like makes so much sense. Like when I talk to people about like how beneficial exercise is to the brain, this is specific to resistance training more so, because when you're doing resistance training, you tend to push yourself a lot more than I guess if you're like sprinting, I don't know, I don't run much, but like you're stressing your body and brain so much in one point. Like if you're doing your 1 rep max, like that's a huge stressor on your brain and your body in general, everything physiologically, that your body has to be able to meet that and overcome that and deal with that, right? Which then when you're hit with other things like, oh my gosh, I have a project due in 12 hours, I have like 2 other things on the go, I have to get this done in time, instead of being like, oh my gosh, like all this stressor, it's overwhelming me, I can't do this. You're like, your brain's more used to that stuff, so you're like, I know I can do this. I know I can get this done, which just then helps you be more productive and everything. Literally, exercise is so great.
I like to comment also on, it was just the other day I was talking about the same thing, like the various types of exercises that, like how it said it's not maybe one type, like basically as long as you're moving, how it said studies on like yoga and resistance training and all this stuff. The other day I was reading something and it's like the best line that I read, and I think I'm going to kind of take this forward with me, was like, what's the best kind of exercise for you, if you ask somebody, and their answer should be the one that I'll stick with.
Yeah.
And I'm like, that's exactly what it should be, because 100%. You're not going to have somebody in here running if they absolutely hate running.
Exactly. And like that's the thing for me, like for so long in my life I wanted to be active, and like I thought that running was the only thing. And I always wondered why I was never working out and never sticking with it. I literally hate running, and now I like don't run like ever, and I'm so much better off for it, right? I walk. I love walking. But like it's 100% what you can maintain, because like I know people who hate lifting weights and they love running, and if that's what's going to get you out and get your heart pumping, get your muscles moving, then obviously like it's not like all these benefits, these long-term benefits, are from chronic exercise. So again, like it has to be something that someone can maintain and someone enjoys enough to want to maintain it.
The point about phys ed in schools, that's a bugaboo for me, because I know as a kid in high school, I took phys ed like every year. It's only mandatory in like what, grade 9?
I think so.
Yeah, I took it every year, sometimes twice a year, just because I loved it so much. Not needing the courses at all, but it's like clearly, like if I got a math class, I'm dumb in math already. Like if I can take a phys ed course before my math class,
100%.
then maybe I'll be able to pass.
And especially like if you're thinking about like kids in like high school who are like, say, aren't good at math, like just like you're saying, and they have physical activity right before it, then their attention is only going to be increased. Like, and their working memory is only going to be increased transiently anyways, even if they don't exercise outside of that phys ed class. So they're just going to be more and more prepared to learn that hard stuff that they're not necessarily good at right after.
Good job.
Thank you. I love talking about this stuff.